Okay guys, today we're going to talk about properties of logarithms. And since logarithms are the inverse of exponents, log properties are kind of the inverse of the exponent properties. So, start off with the product property. So when you're talking about exponents, if you have two numbers that are the same, that's called the base, with different exponents on them, and they're multiplied together, you'd add the exponents. So the 6 is the 2 plus the 4, right? Remember that? So when we come to logs, 5 to the 6th power is this thing right here. So log base 5 of that would equal 6. This thing equals 6. Remember, the log is the power, or the log is the exponent that of the base that you need to get the thing inside the parentheses there. So this would be equal to 2, and this would be equal to 4. So what we're really getting at here is this next step here, because 5 to the 6th, like we just said up here, is 5 squared times 5 to the 4th. So 5 squared is 25, 5 to the 4th is 625, 5 to the 6th, or 5 to the 2nd times 5 to the 4th. That's how the log property of the product property works for logs. And to write it in the general form, you write this right here. So log of two things multiplied together, you can separate it into two separate logs. Or to go backwards, if you have two separate logs with the same base, multiply those together and write it like this. So that is the product property for logs. So two multiplied inside a log, you can separate to two separate logs, and vice versa. So the quotient property is similar. So for exponents, it just looks like this, right? You have the power on the top minus the power on the bottom gives you that. 6 minus 2 is 4. Okay, and if we're looking at it from the log point of view, 4 to the 4th is 256. So log base 4 of that would be 4. 4 to the 6th is 4096. So this is equal to 6, because 4 to the 6th equals that. And this will be 2. So the log is always the power from the exponent way. So 4 equals 6 minus 2, right? So multiplying becomes addition when you separate the logs. Dividing becomes subtraction when you separate the logs. And to write it one other way, remember 4 to the 6th divided by 4 squared is 4 to the 4th. This is 4 to the 6th. That's 4 squared. And dividing those is the 256, which is 4 to the 4th. So yeah, that's still same thing. 4, 6, 2. And to write it in the general form, used x and y this time instead of a and b. So log of x divided by y, separate it and make it log of x minus log of y with whatever base. It works with any base. And by the way, real quick on the product property one, the little b for the base is different than the big B. I think you realize that, but just to point that out. Last one, product property, or sorry, power property. So this relates to the exponent rule of power of a power. You multiply them and get 2 to the 10th, right? So if the exponent rules you don't remember very well, you might want to review those and remember how those work. Watch some videos or something, ask me to go over it with you. And because if the exponent rules don't make sense, the log rules will be a little confusing too. But so the key on this one for the power property is it takes 5 times as many 2's multiplied together to get 2 to the 10th than it does to get 2 squared. So the 5th power means you've got 5 2 squareds multiplied all together. 2 squared, 2 squared, 2 squared, 2 squared, 5 of them. And each 2 squared is 2 times 2, which gets you 2 to the 10th. So this multiplies by 5 how many 2's you have multiplied together. Okay? So when we convert that to logs, because log tells you the exponent when you have another power on the outside is going to be multiplied. So you're multiplying the number of times. So when you're doing that with a log, the power will just come out here. So 4, I changed the 2 squared to a 4. So 2 squared to the 5th, the 5 will just come out because the log is saying how many of these do I need multiplied together? You need 5 times as many. So just get rid of that exponent and say 5 times whatever log of 4 is, base 2. So this one is a little tricky to get your mind around. You might want to pause and think about it for a second. But in the end, it's really one of the easiest ones to do because all you have to do is take the power and put it out front. So that is the power property for logs. Okay, let's do some examples and that will be it. So example A, we want to expand this. Expand means separate everything out as much as we can. So remember, everything in here is being multiplied together. That's a 25 times x squared, right? So we can separate it out into log base 5 of 25 plus log base 5 of x squared. That is the product property. But we've also got an exponent here, so we can use the power property and change this to be 2 log base 5 of x. And by the way, 5 to the 2nd power is 25. So log base 5 of 25 is just 2. So that would be fully expanded. Make sure if there's anything you can expand, expand all of them on these examples. Okay, next one. We've got division in there, so we can use the quotient property to start with. Log of x squared y squared minus log of z to the 4th power. Okay, both of these can expand further. So first I'll use the product property on this one, then I'll deal with the exponents in a second. So that would be log of x squared plus log of y squared. That's separating those using the product property, minus log of z to the fourth. And those exponents are all just going to go like this with that last property we talked about, the power property. So you can do some pretty interesting things with logs sometimes, because multiplication and exponents and stuff, it just becomes simpler, like addition and constants. Like that whole piece just became a 2 at the beginning. Anyway, over here. Sorry. Getting too distracted. Oh, that was supposed to be y to the third. My bad. That's a 3 up there. And then minus 4 log of z. That's as much as you can expand it. Okay, sometimes you want to go the other direction and put stuff together. So instead of expand, that's called condensing. And this can be useful, especially if you are trying to solve equations that have multiple logs in them. You can get all the logs together. So anyway, this one, it'll be easier if we do the 2 adding ones first before we do the quotient rule. So, but actually first of all, I'm going to put that 4, so that's going to become log of 3 to the fourth with the power property. Sorry, just a second there. There we go. Okay, so the 4 becomes a power on the inside. We're just going backwards of what we did, like right here. We're taking the 2 and putting it there, in this case, the 4. Okay, now, actually, it could work better if we did these 2 first, but just to show you how it'll work, I'm going to do these first here. So I'm going to leave the one in the front, log of 3 to the fourth power. You can just leave that as an exponent. You don't need to multiply it in your calculator or anything. So this part right here would be log of x over y. So log of x over y. That's the quotient rule with the subtraction there. And then log of 3 to the fourth plus log of that. We're assuming all these logs have the same base. It doesn't matter what it is. The 3 to the fourth is going to be multiplied with the x over y, which will mean it's going to be on the top. 3 to the fourth x over y. And that is all condensed into 1 log instead of 3 logs. Yay! Okay, last example here. 2 log a would become log of a squared with the power property. Same thing here. Log of b to the fourth minus log of c. Okay, this time I'll do it what probably would have been the easier way on the last one. I combine those 2 first and we say log a squared b to the fourth minus log of c and the minus will become subtraction when we condense that last part. Just like that. Okay, so we're just going to use these three properties and do expanding and condensing on this assignment for today. And then next time we're going to use this stuff to solve equations with logs in them. So yeah, we'll talk more about that next time. Thanks for watching and getting your notes done. And yep, have a great day, everybody.